Well, hello and welcome to this e-learning course of EuroPCR 2020. So I think we have a very interesting session. It is a session which concentrates on the selection of appropriate devices for retrograde CTO cases and is sponsored by Asahi Intecc. And we have some very good experts in the field of retrograde CTO PCI, which is Paul Knaapen from Amsterdam and my friend Masahisa Yamane from Japan. Hello. So I'm happy to have you all here for this interesting session. And I just want to focus a little bit on the key objectives of our session. So the session objectives of this session is to enlarge the spectrum on retrograde device selection, to increase your knowledge of new upcoming CTO devices, and to have an interactive discussion about available CTO wires and devices, and to learn how device selection can lead to procedural efficiency. And therefore, I'm really happy to have the next speaker, Paul Knaapen, to show us about device selection retrograde CTO PCI. Please, Paul.
Okay, thank you, Kambis, for these kind words. These are extraordinary times, and unfortunately, we could not have a physical meeting for EuroPCR this year. But I think this is good, the alternative to try to get the education going. And I've been asked to give a live in the box presentation about a retrograde PCI case we did at our center. And I'd like to walk you through it with all the tips and tricks that we've come to grow in the custom of. So this is a 60-year-old female with AF and a normal left ventricular function who presented herself with dyspnea a couple of years ago, who displayed two vessel disease of the LED and the CTO of the right. The LED was fixed on an FFR-guided PCI procedure, but she had persistent symptoms, and then non-invasive imaging with PET and CMR revealed a preserved left ventricular ejection fraction with wall motion abnormalities in the CTO area, but a large area of ischemia and viability. So we decided to put her up for PCI of the CTO artery. These are the setup shots, and as you can appreciate, it's a double arterial access. There's an unplot scatter 0.75 French to the right, which is the CTO artery, and there's an EBU 3.57 French through the wrist on the left. And you can easily appreciate that the JCTO score in this patient is very high. There's a blunt cap. It's a lot of calcification. It's a long lesion. It's bending. So it's a JCTO score of 4, and it would have been 5 if there would have been a previous attempt, which was not the case. You can also appreciate that there's collaterals coming from the circumflex, which are very tortuous to the posterolateral branch, but also there appears to be some septal connections from the LAD to the PD. So this now warrants a strategy how to optimize a PCI CTO in this case to be as fast and efficient as possible. So again, the JCTO score in this patient is very high because of the ambiguous cap, which is blunt, the calcification, the bending, and occlusion length. So it's a JCTO score of 4, which means that antegrade wiring or the retrograde wiring approach is very likely to fail. So this is very likely to be a dissection reentry technique, because wiring in these cases, no matter with the sophistication of wire these days or the operator skill, is very likely to fail. So what we've been grown accustomed to use the hybrid strategy in Amsterdam, which we take a look at 4 features on how to tackle a CTO, which basically looks at the proximal cap, the lesion length, the distal target for antegrade dissection entry, and the collateral channels you have. And in this case, if you walk through the algorithm, we decided to go for a dissection reentry strategy with the reverse card as a primary approach in this case. We all know that interventional collaterals are needed to get retro. We can use bypass grafts, the septals, or the epicardials. In this case, obviously, it's a non-post bypass patient, so bypass grafts are not an option. But we did have the septals and the epicardials. And as a rule of thumb, I can advocate that if you have the choice between an epicardial or a septal, septals are more safe, they're more easy, and even if you make a complication, the the results will be quite benign as opposed to the epicardial. So in this case, we have the choice both for the septals and the epicardial, and we chose to try a septal engagement first over the more dangerous, the epicardial approach. So when you talk about the materials, and we'll go into more detail with the other speakers during this talk, but I can say that you only need a few wires if you want to get retro, either with the septal or the epicardial crossing. And my workhorse wire to get retro from the septal or for the epicardial is an Asahi Xeon. If that fails, I'll switch up to a Xeon Black, and if that fails, I'll go to a Fielder XTR. And in more common day technology, we have come also to use the SUO 3. So SUO 3 is new technology, very low tip load, and is very well equipped to navigate through a very tortuous anatomy. So that has been sort of become the default setting for the epicardial channels, as well as very highly tortuous septal channels. So these are the imaging that Dr. Alexander Knaapen and I myself did on a live case some time ago. First, you try to engage in the septal with a workhorse wire. In this case, it was a Xeon Blue with a more pronounced tip to get yourself navigated into the septal. And then you have two choices how to navigate through the septal. One is through tip injections and then sort of navigate yourself through with the knowledge you have. Or you can do what we did in this case, blind septal surfing with a Corsair Pro 150 and a Xeon. And this is actually the first store fluo run we did. And it goes to show you that even if you don't clearly see those septals, a blind septal surfing can be a very safe maneuver to get yourself through the channel. And this was just the first run. And it just goes to show you that you can go very fast through such a procedure if you choose the right the materials and the right selection of the MCs and wires to get yourself through that septal. There's no rocket science behind it. You make sure from the contralateral injection that you actually are in the position where you are. You can see here that we're in the PD, and then you need to advance the microcatheter through the septum. So please watch the hand of the operator of Dr. Nutt, who is now positioning the wire that it's lying free within the PD, and then doing Corsair spinning. And Corsair spinning basically means it's not as much about pushing as it is rotating and pushing the force. So his left hand is on the OKY connector and then transmitting the torque, and his right hand is now counterclockwise and rotating 10 to 20 times, then releasing tension, and then slowly with each heartbeat, it's predominantly in the diastole that you move, you'll advance the microcatheter. Also, please note on the live image that the guide is being pushed back. So it's an interplay between pushing enough, rotating enough, but not pushing too hard so that you'll push out the guide. The second operator can help in this case by fixing the guide, so you'll have more push. But generally, this is a strategy that takes a little bit of time to maneuver yourself through the septum. In case you don't get through the septum, there are some tips and tricks you can use. You can enhance the support by getting a firmer guide, getting a guide extension, getting an anchor balloon, or a more supportive wire. You can dilate the track to make more room. This works for the septums and is contraindicated in the epicardials. Or you can downsize your equipment. In this case, it was a Corsair Pro, but you can downsize it to Corsair XS, which we'll hear later from the other speakers about, or Caravelle. Please note that if you pass these with smaller devices, then you're going to have less push once you get to the distal cap. So there's pros and cons. I usually start the septum with a very bulky catheter like a Corsair Pro, that if you pass, you have as much push as you can once you get to the distal end. If you are lucky enough to have the wire already in the retrograde procedure and you can jail it, you can also have more push with the trapping device. So in general, about 90% of cases, your microcatheter will pass, and you don't need these auxiliary measures in about 10% of cases or so. And you can see that the Corsair Pro right now is sort of stuck at the base of the heart between the junction of the septal and the PD, but it's often just to build up torque and tension and just wait a little and give it time. retract the wire just a little bit so the wire is free, and usually will go once you build up tension and torque within a few rotations or so. As you can see right now, it's sort of stuck here. You don't necessarily need to balloon the track, just give it a little bit of time, and once it passes that junction, often it will go more swiftly. As you can see right here, it passes the junction, and then it will often move in a more swift manner towards the other side. Now again, now we're at the distal cap. So we've moved ourselves from the septum to the distal cap. And now instead of wiring, we are now intentionally trying to dissect. And this is often done with what's called the knuckle technique. So you fold over a soft polymer jacketed wire. This would typically be a fielder XTA, or if you need a more firmer knuckle, this will be a pilot knuckle. Not to wire yourself through it, but as you can see, you form it a knuckle. It has an umbrella shaped, and you intentionally dissect through the body of the CTO. And this is a very safe maneuver. It's often more safe than taking stiff wire, which may exit the vessel, because a knuckle wire will virtually never exit the body of the vessel. More recent contemporary wires are now with Asahi with the Gladius Mongo wire, which is a dedicated wire to knuckle, but it's not available in Europe yet. I've been fortunate enough to be able to test it in other foreign labs for a couple of times, and it shows great promise with a firm knuckle that will retain its shape to try to navigate yourself safely through the artery. Then once you get up to the body of the CTO, you're going to have to set yourself up for what we call is a reverse cart. And reverse cart basically means that you want to dissect from an antegrade manner, from a retrograde manner, have overlying knuckles, and then balloon the subintimal space to fenestrate it and to be able to redirect your retrograde gear into the antegrade guide. And this is well described by Brilakis in his book and by many others, but I can highly advocate trying to read this material. So once you get retro, as you can see right here, we've knuckled ourselves all the way up into the proximal cap. You'll need to puncture the proximal cap. And as you can see right here, there's a scheme for it. You can do it with soft polymer jacketed wires, typically fielder XTR or fielder XTA. You can do it with intermediate type S wires. This would be the Gaia family, Ultimate Bros, or Gladius. Or in this case, it was a very tough lesion. We switched it to the Confianza Pro. So the operator, as you can see that Alex now did, is punctured the proximal cap, went into it, seems to be overlaying with the retrograde gear from two angles, and then try to find the vessel architecture by removing the stiff wire, and then by inserting a soft polymer jacketed wire, in this case a fielder XTA, to see whether you are in fact into the architecture. And this is a key point in the procedure, as you can see right here. The Confianza Pro 12 is now being removed from the antegrade gear, in this case a Corsair Pro 135, and now a soft polymer jacketed wire, in this case a fielder XTA, is being inserted into the proximal gear. And now you try to see whether your knuckle will track the retrograde gear in order to set up for reverse cart. And now this is a key point right now to look at what happens when this knuckle is being formed. The retrograde knuckle traveled up in a very sufficient manner, and now look what happens to the antegrade knuckle. It forms into this huge loop. It obviously tells you that this is outside of the architecture of the vessel, as you can see right here. So apparently the antegrade cap puncture has caused a perforation. The Corsair was advanced, but the knuckle is now telling you that you're in the wrong space. So at this point in time, it's good to recognize it. You should retract your gear and try again. So to try to find some new architecture, we employed what we call the scratch and go maneuver. The scratch and go maneuver basically means that you intentionally try to dissect with a stiff wire, go into the subintimal space, find some tissue, and then do the procedure again, where you try to knuckle again. So could somebody from the host now play this, because I cannot start this loop from my end? Yes, thank you. So as you can see right here, we started again from antegrade, now taking a Confianza Pro, get it into beneath the vessel in the subintimal space. Then once we had tissue, we advance the microcatheter, exchange again for soft polymer jacketed wire, and now try to knuckle our way down again. And as you can see right here, this is a completely different form of a knuckle. This knuckle is now tracking vessel architecture, where it was in the pericardium before. It's now tracking the vessel, and now you have what we call overlapping knuckles. And this is when, especially when you start doing reverse cards for your first time, this is what you want to see: a knuckle from retrograde, a knuckle from antegrade, and having an overlapping space from two projections, as you can see right here, because now you can start ballooning the subintimal space and then try to get re-entry. In our lab and most labs across the world, it's now customary to do guide extension facilitated reverse card, because then you make the distance between your retrograde gear and your antegrade gear as small as possible. So as you can see right here, we are ballooning the subintimal space and we are inserting a guide extension, in this case a guide liner, and you balloon the subintimal space, and you take the guide liner into the subintimal space, and so you prevent recoil. Now you have a very short distance between your guide extension and your retrograde gear, and then you can basically take any kind of wire to try to get re-entry. Usually, most of us take polymer jacketed wires like Pilot 200 or Gladius, but you can use any type of wires like the Gaia family or even Confianza Pro 12 if you have to navigate through a lot of calcium. If the distance is short, it's going to be very, very safe to do so. So this is the reentry phase. In this case, it was a Gaia wire. You can see the wire going back and forth into the subintimal space, and finally, as you can see right here, getting into the guide liner. And now you have externalized. So you advance your retrograde gear, get it into the guide liner, then get a long wire like an RG3, and you externalize. So you basically now have the heart on a string, and you can basically do antegrade, ballooning, and stenting through the externalized wire, in this case, the RG3. You then retract your retro microcatheter, not exposing the septum, so it needs to be in the septum, but in the distal part of the CTO. And it's very important that you don't make antegrade injections as of yet, because it's dissected, you can propagate, cause hydraulic dissections, and ruin your entire result. So the stenting and ballooning should all be done with retrograde injections, as you can see right here. It's also a big advantage of the retrograde approach that the externalized system has a lot of push. So even though it may be a lot of calcification in there, a lot of bending, the delivery of balloons and stents with the retrograde approach through the externalized systems are very supportive. Also, once you get into the retrograde manner, you don't need any contrast anymore. So for example, if you have a patient with renal failure, a retrograde approach might be far more wiser and more safe for the patient than an antegrade approach, which is going to be a lot of contrast use. In this case, I think it's very important to highlight that we now more and more use, after stenting and ballooning, use IVUS or the OCT imaging to optimize durability of results. I think we've come accustomed to the fact that our success rate of PCI CTO is now 92% or so in the major databases. But now we need to make sure that these stents stay open. So invest a little bit of time and money into getting stent apposition, stent deployment, stent sizing, and checking that with imaging, either with IVUS or with the OCT, to make sure that you get a durable result. Nobody wants to have a successful CTO and the patient coming back with a full metal jacket that is occluded 1 year later, which is going to be, for the long-term prognosis, a very poor one. So try to invest a little bit with IVUS and OCT once you have a successful case, to try to optimize the stent facilitation. So this is then the final result of this sort of textbook case reverse card, even with a complication. But the patient is doing fine and went home the next day. And I can tell you that this case was done in 2017, that 2020, I just recently saw the patient. He's doing fine and well, and had another procedure on the circumflex, and the stent patency of this right coronary artery was still excellent. Even though it's a dissection reentry technique, we know that if you don't have residual stenosis and you have TIMI3 flow with preservation of all branches, then the results are as good as intimal stenting in the long-term outcome. So in conclusion, I'd like to state that the retrograde approach significantly enhances success rate of PCI of the CTO, and that multiple steps are needed. You need to select the channel, you need to wire the channel, you need to go through the channel, you need to travel through the body of the CTO. You're frequently with reverse procedures. In over 75% of cases, you're going to be committed to reverse card, and you need to have all the steps and troubleshooting techniques to deal with complications, because complications are more frequent with retrograde approach than with antegrade approach. So learn all these tips and tricks and be prepared to deal with complications. But once you have sort of gotten this, your toolkit and your skill set, your success rate is going to be 90% and higher, which is going to be worthwhile. Thank you, Kambis.
So thank you very much, Paul, for this excellent case. So I think a very important thing here, even if we're talking more and more about retrograde approach in this session today, is the crucial point here was the correct puncture of the antegrade cap.
Exactly.
And this is sometimes a problem, at least if you don't have the opportunity for IVUS, like here, because you didn't have any side branch. And if you don't know where to puncture the wire, because there was some ambiguity at the proximal cap. So because once you started the case, I was thinking, why are they going directly retrograde? But the retrograde wire gives you the answer where to puncture. So sometimes you still have no idea where to puncture, right? And even retrograde wire can't be placed. So we are looking more and more and hoping that someday forward-looking IVUS could help us. But if you fail to puncture, one advice sometimes is that we have to puncture really against the resistant point of the proximal cap. So this may sometimes help to facilitate and not to let's say to just go exit of the vessel. And another important point, what we saw here, is even if your wire and your microcatheter was outside the vessel architecture, the retrograde and reverse card maneuver could compress, so you didn't have any perforation there. So this was also very important to understand that antegrade exit on the proximal cap may not automatically result in perforation in this kind of cases once your retrograde wire is in subintimal space and your antegrade wire was redirected. So therefore, the scratch and go in this case was very, very important.
Yeah, so thank you, Kambis. And so the first thing to highlight, and what you alluded to, is that if you have ambiguity of the cap, you can solve it by going retro. Because once you get retro, you immediately know where the proximal cap is once you get there on a wire-based strategy or with a knuckle or whatever. So that's what we did in this case. But still, even then, as shown in this case, it can be very difficult to still puncture the proximal cap. So in these days, I am moving away from proximal cap puncture if I'm not sure, or scratch and go, and do what we call the base maneuver. You need a little bit of segment where you balloon and you tear and make micro dissections, and then you take a soft polymer jacket wire against the balloon to navigate yourself into the subintimal space. But in this case, we didn't have that option because the lesion length was too short. But exactly as you say that we did make a complication, we exited the vessel, but it's very important to realize that at a very short stage before you start ballooning it, because now the small hole with microcatheter would have gone very big if you start ballooning it. And also there's nothing to solve a complication than to solve the case. So in this case, going back, doing an alternate maneuver from cap puncture to scratch and go and start all over again is the safest way to finish the case. After stenting, it was completely dry. So I think there's a lot of tips and tricks in this case for people to realize that things can go wrong. You can have complications. Things might be difficult, but try to iterate, try to move on throughout the case and come up with solutions and a lot of tips and tricks, and be very familiar with all the documentation that's out there by books from James Spratt or Manos Brilakis, and be very well equipped with all the steps and potential complications.
So I want to ask also Dr. Yamane, because Japan has a very, very high experience on IVUS over many, many years. So my question is, at which point are you going for the IVUS? So once you see you have a knuckle overlapping, and you know that maybe you have a very, very long occlusion there, and you have a long stand length. So would you go for IVUS before reverse cart to understand where to do your reverse cart, or would you just say, okay, no, I do my reverse cart in front, and after I do only IVUS for stand optimization in this case?
Thank you very much, Dr. Masayekhi. Actually, I may not be the best person to answer the question because I have so many hours spending the time with you, European doctors. So sometimes, most of the time, I do the complex CTO procedures without the benefit of the IVUS. But although this is not the best advice for the Dr. Knaapen because he's a professor of the cardiac imaging as well. But the CT scan and IVUS together, probably we can reasonably suspect where the vessel is running, even the hiding behind the calcium. But having said that, still we need an IVUS if you have trouble in re-entering with the antegrade and retrograde wires. Sometimes the antegrade subintimal or retrograde intimal. Those are the quite difficult situation, especially the retrograde intima is circumferentially calcified. So in those cases, probably it's a very high time to use the IVUS. But having said that, Paul also mentioned that the 3D images are pretty much important since he is already a professional. So probably he doesn't need the some 3D mapping in his brain, but probably it's easier and safer to say for the beginners. Probably we need to have some imagination of the 3D structure running of the coronary, especially RCA and the LAD, which are pretty much backbone of our profession, right?
Yeah, I think Masa, that's very important comment that you make, because more and more we're now preparing these cases all around the globe, but in Asia and specifically, you are at the forefront of that with non-invasive imaging, for example, with CT, to prepare yourself. Because if you have ambiguity of the cap, CT will help you a lot and prepare you. And you don't have and the IVUS is great, but sometimes, like in this case, you cannot do IVUS because you don't have a side branch or anything. But on the other hand, even if you have to do it, it will prolong the case. If you can have this information based on CT and you can prepare your case and you do it a few weeks prior with very little additional radiation and contrast, it will facilitate you and provide you with more information. So Dr. Yamane, that's a very valid comment. I think just as with TAVR and EP procedures, we are utilizing non-invasive imaging more and more with anatomical information with CT to sort of prepare ourselves what the anatomy is going to be and facilitate the procedure.
So thank you very much, Paul, and thank you very much, Masahisa, for this great discussion here. So I think we should go on to the next presentation. Okay, I will focus a little bit more on retrograde collateral passage and also on the new devices which helped us a lot in the last years, and for retrograde collateral passages, and also for talking a little bit about future development and which devices are coming up in the near future. So I think in 2010, the market launch of the Corsair from Asahi Intecc really helped a lot on the retrograde approach, because the implementation of the reverse cart was extended by this publication in JACC Cardiovascular Intervention in February 2010. From this time up, the reverse cart procedure was more and more easy, because you had the microcatheter which was on the retrograde cap, and you could really change wires and stiffness and different wires, from polymer jacket wires to really penetrative wires, for setting up your reverse cart maneuver. So the history actually of the coronary microcatheter started in 2011, where Corsair was launched also in Europe. And then in 2016, a more low-profile microcatheter came up from Asahi Intecc. It was the Carvel microcatheter. And now in 2017, the Corsair was optimized also with his tip and the shaft, and it was the Corsair Pro in 2017. And now actually the Corsair Pro XS is launched in Europe in 2020. So I can show you what the new technologies and are really gives us more possibilities. Here you can see a retrograde approach of a suocerofree with a Carovel on this epicardial collateral, and also how easy it is to follow with this low profile microcatheter retrogradely. So you can see how fast and how nicely you can just wire this kind of very tortuous epicardials nowadays. And with the suocerofree, it's a very, very low profile, a low tip load wire, and it just slaps through the epicardial connection here. So here you see another example, very tortuous example, an epicardial going from the circ to the right coronary artery. And now you also see the behavior of the suocerofree here, how amazing it is with these tortuosities, and still the tip is controllable. Here you can see that I control the tip very, very nicely and controlled, and then finally could pass and solve the case. Another example is here a boss cabbage case. Actually, it was done in I think in Riga. There was a boss cabbage patient where I was invited with a LED occlusion. And here you can also see very, very tortuous epicardial connection. And again, the setup for suocerofree with the Carovel. And just look at the wire performance here. And this is really amazing because this is a 360 loop and just was done by this wire. Then finally the retrograde wire was in the antegrade guide, the tip-in was done, and the antegrade guide could brought down, and finally we could stand the vessel. So this scenario is the retrograde approach with the new technologies of Carovel and suocerofree, which is an extremely good backup for epicardial collateral wiring, was excellent and solved the cases. And here a little bit more advanced, let's say it's very, very tortuous collateral connections to the LED from the conus branches, and still here you can atraumatically wire here these epicardial connections to set up for a retrograde marker wire and finish the case here in a patient with a renal failure. So when you compare the microcatheters from Asahi Intecc, you see the Asahi Corsair Pro, which gives a lot of wire support, pushability, and crossability, and is torqueable, as we have seen in the video from Paul. So the Carovel actually is a low-profile microcatheter, is very flexible and trackability, doesn't give you so much wire support. It's important to know. Paul also announced it, and is not torqueable. This is really important because if you over-rotate the Carovel, and the tip is fixed, the tip may be destroyed. And this is the solution nowadays, that you have a low profile microcatheter, which is the Corsair Pro X, which is flexible and it has a high trackability, and still you can torque this microcatheter and advance the microcatheter forward. So here you can see the specific key features of the new Shinka shaft. You see the Asahi Corsair Pro with a 1.3 French size to the entry profile, and the distal shaft is 2.6 French compared to the Corsair Pro XS, which has 1.3 French entry profile and only 2.1 French distal shaft. And here is the cross section. What you can see actually is that the tip portion is you have only some wire ropes there, and then you see that there are 14 wires braided inside this new shaft, which gives a lot of torqueability. But please, what we have to remember is that almost, especially on the retrograde approach, when we have a lot of calcium and the tip is fixed in calcium, and we see that the tip is not advancing, we should really take care not to over-rotate the devices. So therefore, once you see you have friction, try to also release a little bit the push on the device. So go a little bit back on the device and see if the wire is still free, because if not, you can over-rotate and damage the tip. Therefore, only 10 consecutive rotations in the same direction are recommended. So coming now back to the new wire technology. And here we have also a new wire which will be launched this year. It's the Asahi Gladius X. And many of you used in the past also the Pilot 200, which is a polymer jacket wire. But maybe the advantage of the Asahi Gladius is that we have more wire control on the tip. This has to do because of the Act 1, which is the same principle like the Suo the Xeon blue technology, that you can control your wire. And the Asahi Gladius next has a 3-gram tip load. And so once your filter XD series is failed to cross the CTO body, you have to understand if your vessel route is clear or it's absolutely unclear. So when the vessel route is clear and you see a lot of calcium, you just can go with higher gram tip load wires like the Gaia 30 or the Confianza. But if the vessel route is absolutely unclear, like in the previous case, maybe after puncturing the proximal cap, the polymer jacket wires are a very, very good opportunity with the knuckle wires, and also the Gladius X could be a great opportunity with a step up, step down strategy. So here you see the tip load again of the Gladius. It's a 3-gram tip load wire compared to the Field XD series, which is 0.6 to 1 gram. So I show you here a case just recorded in the past with the Gladius wire. It's a case where we end up in a reverse card. Sorry for the image quality here. And we had the Integrate and Retrograde knuckle. Both were done with Gladius wires, and we set up for reverse card. Even after the reverse card, we still could control, after the knuckling of the wire, we still could control the Gladius wire, and the Gladius could be engaged towards the Integrate mother and child catheter. So even after the knuckle, as you can see here, the wire could be retrieved and then could be engaged into the mother and child catheter, and finally we could open this huge right coronary artery. So to summarize, I think the new microcatheter and wire technology expand the possibilities, especially in retrograde CTO PCI. Low-profile microcatheters combined with the SUR-free technology decreases the risk for retrograde channel passage. And the Gladius X is the first polymer jacket CTO wire with the new dual core technology and give the CTO operator good wire control. And I think polymer jacket wires with higher tip load and controllability are a good choice for conventional reverse card maneuvers. Thank you very much. So now we hand over to Dr. Yamane from Japan. Thank you very much, Masahisa.
Very much, Dr. Mashayekhi. Okay, my topic is additional new information regarding the guide wire and as well as the microcatheter. So probably as you already heard that this is a typical example of the circumflex CTO, which is one of the most challenging cases. Proximal cap ambiguous, long CTO, and distal vessel is very small, and collateral is found on the epicardial. No calcification, but the bending inside. So our plan for revascularization is proximal cap puncture by the IVUS and retrograde dissection reentry as well. So in this case, we try to navigate the IVUS first, and we could find the proximal cap, but with the pendulum motion of the circumflex, especially the middle one, integrate wiring was almost impossible. So we explore the retrograde SUO03 on the Corsair Pro XS first, and then we can get very close. Again, integrate puncture impossible. That means probably the current reverse cart impossible. So in this case, just balloon inflation over the proximal through lumen, not inside the CTO. It is so-called the extended reverse cart was attempted, but since you know that the antegrade balloon inflation inside the vascular lumen and very stiff wire with the retrograde, after several times attempt, probably you can reasonably expect that some kind of a dissection and the hematoma occur if that extend to the more proximal portion, such as bifurcation, as well as the left main, catastrophe can occur. So desperately that we deploy the stent because the idea is just not only gaining the space, but also just confronting some potential dangers, such as hematoma extension to the proximal site. So after stent placement, retrograde Gaia Next 3 actually puncture through the side of the stent, so crossing into the proximal site of the circumflex as well as the left main, and which was confirmed by the iris. But amazing thing is, even among the stent struts, the Corsair XS did cross through the stent struts to the integrate guide. So after the externalization of the guide wire, and then we can obtain the final outcome after deploying a couple of stents. So this is some exceptional case, but still the use of the new microcatheter and combination of the new guide wire will be of help. So this is the challenges in the retrograde reverse cart. Since we know the conventional reverse cart, which is left hand, but most of the time we use so often with the guide extension right here in the middle, but the directed reverse cart or the guide extension directed reverse cart is the most popular things. But as I described in the right-hand panel, extended reverse cart, on the other hand, is a very much difficult and sometimes potentially dangerous if we explore the retrograde subintimal space all the way to the proximal true lumen. That's how we have trouble sometimes. And even if we compare some other competitor of the microcatheter in the tortuosities, as Dr. Masayekhi described, in a very tortuous telephone cord structure like epicardial collaterals, Corsair Pro XS can track very well to the distal end. But the way to behave is something a little bit noticed, is that response is a little bit slower than you anticipated with the other microcatheters, such as the Corsair Pro or the Turnpike LP. So you need to wait only a couple of seconds to transmit the power and advance forces at the tip. That is the key for successful advancement. But other than that, probably you have more freer and more higher resistant part goes through. So this is a specification already shown. Next. So probably last example where the middle part of the RCA occlusion, after giving rise to the large acute marginal branch, which is a part of the donor vessels to the distal RCA. So in this case, not only the CTO vessel, but we don't want to lose the side branch because this is one of the major donor vessel as well. So in this case, assessment will be the proximal cap tapered, lesion length more than 20 millimeter plus beginning of the bending portion. This vessel is also diffuse disease. Collateral vessel is fine on the epicardial. Calcification absent, bending present. So our plan is a branch protection because during the procedure, if the donor vessel will be sacrificed, probably the patient may suffer from the large ischemia, not to mention the myocardial infarction in the worst case, and retrograde dissection reentry as well. So in this case, we started with the retrograde. So you can see the LED provides a very much tortuous segment as well as a septal channel. So we found out the distal septal provides a very good collaterals. So after the putting the safety wire of the distal LED, we can use the SUO03 as Dr. Mashayekhi described, and the combination with the Corsair Pro XS. SUO03 nicely crosses to the distal part of the PDA. But the real problem is that this entire LED as well as the septal is a very tortuous. So as you can see that even if you advance the Corsair Pro XS, you may appreciate some delay of the response at the tip. So you need to have a little bit resistance and resilience to have the microcatheter reach to the epicardial part of the vessel. But once you reach to the target vessel, probably you can just inject to make sure that one, you are inside of the vessel, two, your direction is right on top, So in this case, we try to use Gladius ES, as Dr. Mashayekhi already explained. We try to do the knuckle at the smallest form, but in this case, we have the same time that the preserve the bifurcation. So we point the direction in the aerial projection. As you can see, the bending here. All we do is just creation of some overlapping inside of the CTO. Now you can see that this is a patent vessel part, which has also the disease. So we have to create the re-entry inside of the CTO, not the outside of the CTO as well. So after aerial projection, LAO projection, both confirm that we can really appreciate some middle of the CTO will be the ideal sweet spot for the balloon inflation. And in this case, next, 2.5 millimeter balloon inflation of the guide catheter extension. And then next moment, actually the Gladius guide wire into the antegrade guide extension. Next, and successful externalization was performed. And next, and then we deploy the stent after not only the main vessel, but also preserve the side branches as well. So probably we can say that the next, if you have the vessel course known, probably we can do the deflection control and the directional control next, like using the Gaia wire or the Gaia Next wire in some countries. If the vessel course are known, and sometimes we can recognize some kind of a very hard resistance. And when we have some resistance, and then we can use some polymer jacket wire, such as Gladius EX and Pilot 200 for the knuckling to the distal vessel. And then we can use either the guide wire based reentry, such as the LAS, or the device-based entry, such as the Stingray system here. So this is already explained. So probably those are the new devices with additional experience. So you can use many ways possible to expand your technique as well as the safety in the very complex procedure.
So thank you very much, Masahisa, for this excellent talk about the new devices. So one important question is about the knuckle, right? So the Gladius gives us, let's say, a lot of power. It's a very strong wire also on the knuckle. But on the other side, my feeling is sometimes that the knuckle is getting a little bit very too big in comparison to other wires like Xeon Black and Fielder XTR. And I would really have your opinion also from Paul, who is doing a lot of dissection reentry, but also from you, Masahisa. What's your experience on knuckle wire of choice?
Thank you very much, Kambis. Actually, yeah, that's a very good point. But usually, if you think about the knuckle, still I am a little bit living in the old-fashioned school. So I usually choose the XT Asahi wire, or as well as recently Gladius. But as you know that the Gladius may have a little bit shorter and a smaller size knuckle. So you can keep it unless you brutally push it very hard, and then that can be very larger. So probably one thing is just keep the knuckle shorter means you need to push a little bit constant force, a little bit time to transmit the power. At the same time, as Paul mentioned, that for the knuckle, we don't have to actually spin the wire. We just push it. So probably a constant push with a little bit of slow motion would be the improved less dissection and less hematoma, I guess.
Yeah, I completely agree with the knuckling technique. It's basically soft polymer jacketed wire. So if you have a Fielder or a Fielder XT on the shelf, that will probably do the job in 9 out of 10 cases. And unless you need far more push, then a Pilot 200 will work, or the regular the Gladius wire. But I do have some limited experience now with the dedicated Gladius wire for knuckling, which is called the Mongo in the United States, and being produced in the EU soon. And they promise us it won't be as big as knuckle as it is with the Pilot 200. But I do agree with you, Kambis, that if the knuckle can be small, then that would be preferable to facilitate the reentry. On the other hand, we must not overthink it. Knuckling is knuckling, and it's an illusion to think that you as an operator will control the size of the knuckle. I mean, you simply push, and it's basically the architecture of the vessel that sort of decides how big the knuckle is going to be, whichever wire you take, although there might be differences. I want to thank you both for your excellent display on how to get retro with these new wires, and also displays very highly that we should be updated about new technology. Gaia is being replaced for Gaia Next. The Gladi is now hitting the market, the Suo 3. They are real game changers, and we should all, as operators, be up on our feet to keep up with this new technology and try to get as much experience as possible. A few comments I do have about we can now, the options to get retro with very tortuous epicardial channels is now so good that we try to seek them more and more. However, I would not like to advocate those as routine choices, especially when you're beginning your program. Sometimes antegrade dissection reentry is also a very good option. It might be more safe. So getting reverse is highly tantalizing and significantly enhances success rate, but we should not disregard the other options. And what I also now see is that we're taking on these very long channels, very long retrograde channels, that we must also not forget the basics. For example, to use 90 centimeter donor guides, you know, the very basic steps that we all need to do. Technology is advancing, and I think you've shown us that in your hands you'll be able to cross almost any retro channel. But let's not forget the basics also. But I think the whole comprehension of basics, advancement in technology, wire skills, but also patient safety will then be effectuated into what choices are best. But this is an Asahi session, and we do have to acknowledge that the fact that these industrial partners are paving the way with superior technology that is unprecedented and is still continuing over the last few years.
Thank you very much, Paul, for this very, very important discussion point. One other point on technical aspects, which I still want to get in this session to discuss, is about the difference of the new Corsair XS. So tell a little bit about his choice when he's taking the Caravelle or when he's taking the Turnpike LP, and what is the new difference of the new Corsair XS? So where do you see the place for the Corsair XS exactly?
Yes, actually, still we are questioning ourselves, which is the best scenario.
Yes.
But as Paul mentioned, sometimes the way I see for the collateral crossing is sometimes we start with a very low-profile microcatheter, such as a Caravera. But once we cross the collateral, sometimes you and I know that we need more support when it comes to crossing the CTO. So in that case, probably we might have need a combination of the low profile first and then more supportive microcatheter. I'm not talking about the JCTO score 1 or 2 CTO, but rather 3, 4, 5 CTO. Those requirements is a very high standard. So one solution, although tentative solution, would be the combination of goodies one way or the other. And next is a more powerful supportive microcatheter, for example. So we need to combine those kind of whole idea to get one solution together, I guess.
So it might be a really necessary complementary tool in our retrograde toolbox of microcatheters in the future. And we still will see how the device is going to be in our hands.
I completely agree. I would like to emphasize that our toolbox is growing bigger and bigger and bigger. So we must distinguish what is overlap between devices and what is actually complementary. In my opinion, you need 3 microcatheters. One is a regular bulky one, which would be the Corsair Pro or competitors like Turnpike. You need an intermediate type of one, which would be Corsair Pro XS or a competitor like Mamba or Turnpike LP. And then you need a very flimsy one, which would be Caravelle, or it would be like a fine cross or whatever. But those are the three types: the flimsy one, non-torqueable; the bulky one, the workhorse, if you will; and then the intermediate one. And if you have one of those three, I think you can come a long way before building your entire toolkit with every microcatheter on the market.
Yeah, thank you, Paul. I really appreciate this summary. So on microcatheters for retrograde approach. So I think we would be happy to see the last slide from Masahisa Yamane for the key learning points of the session.
So probably this is already mentioned by Kambis, simplified wire escalation based on the CTO cap ambiguity. That is probably basic for the integrate as well as a retrograde cap ambiguity as well. So probably if you have polymer jacketed tapered wire such as a feeder XT, feeder XTR, XTA, then if you have idea of the course of the occluded vessel, yes, probably you can go the stiffer tapered wire such as Gaia Second or the Gaia Next or the Confianza Pro. If you don't have the idea of where the vessel is, probably we can go with the Knuckle as well as Ultimate Pro 3 gram or the Gladius EX or the Pilot 200 wire. Challenges in the collateral crossing by guide wires will be a lot of challenge if you dichotomize those kind of anatomical problems. You have to deal with the side branch at the pole or bent, or the corkscrew aspect, or the fine high-frequent tortuosity and visualized segment. But what do we choose for the guide wire next? Probably we need to have a composite core non-tapered wire first, such as a Sion, SO03, Sion Black, or the feeder FC, or the Judo wire Pilot 50 in the past. But sometimes in the last resort would be the tapered wires, such as the feeder XTR. The way to cross the collateral channel tracking will be the surfing, as Paul mentioned, but this is only the septal. But the other else, probably injected guided, is the most probably a reproducible way for the every learner of the CTO PCI. How to handle the guide wire if we prefer to use a talker device, probably not big rotation. And keep in mind that the guide wire itself is a very weak support. So we need to, or the better to advance a microcatheter to the close to the tip of the guide wire inside of the collateral. So probably when you choose the microcatheter, I can summarize that the wire support or the pushability or crossability or the talkability or the behavior of the heavy calcification. If you focus on those 4 or 5 characteristics, probably you can reasonably pick up the one of the best microcatheter. So if you go down to the low profile, probably you can choose the Carabera, Fine Cross MG, Mizuki, FX, or the Micro 14. But you really need to have some talkable microcatheter, which is a more recent one. Probably you may pick up the Corsair Pro XS, Turnpike LP, Fine Cross GT, Mamba Flex, or the Micro 14 EX, which can deal with any type of the collateral, not only the septum, but epicardial, CC1 or 0, or the AC collateral channels. And there is a chance of going through, even in the heavy calcification. So overall, the key point, probably anatomy dictates the CTO PCI strategy. This is all goes through for every experienced operators as well. The problem remains with regard to the proximal cap and distal cap ambiguity, long CTO, bending, calcification, and complex collaterals, which are remaining the very much big issue for all of us operators. But since the skill set needs some time to grow and mature, while the technology seeks some kind of the innovation to provide us more easier solution. So probably controllable guide wires such as a Gaia Next will be the ideal for the short, straighter CTO, but versatile microcatheters, rotatable, low profile, combination with some game changers such as a SO03 for the collateral crossing required for the complex CTO without sacrificing the safety profile.
So thank you very much, Masahisa, for the final key learning points. I think it was a very great teaching session on new microcatheter and wire technology. And I really appreciate your time, Paul, as you're on call, and Masahisa, as the dinner is already ready, I think, in the background. So thank you very much. And it was great to see you again. And I hope we will see each other in 2021 at EuroPCR. Thank you very much.
I bet.
Thank you,
Thank you very
Kambis.
much,
Thank you,
Kambis
Masa.
and Paul. Thank you very much.